Good morning and good afternoon to everyone who have chosen to be with us today. We are on 6th session of Digital Solutions Summer Series, and today we welcome AMP Technology, is the company we are hosting today. Like a very brief intro, AMP provide digital solution for energy companies in energy markets, and with its vendor agnostic platform, it offers remote monitoring and management for portfolios of renewable hybrid energy system. Today we welcome Sivet to as he is now our speaker of today. So he's the CEO and co-founder of AMP Technologies. He leads a team dedicated to simplify the management of portfolios of CNI, solar, and hybrid system. He worked on PV mini grid deployment and operations, and also he holds a PhD in atomic and laser physics from Oxford University. Without taking much of time, I welcome Sivet to this session, and I hand over to you to help us skim through in the presentation. Welcome again, Sivet.
Thank you, Jenny. It's a pleasure to be here and to share a little bit about our story and also what we're doing in the market, hopefully of interest to your viewers today. So I'm gonna start by sharing my screen. Okay, so to say a few words about who we are and how we got started. You already gave a bit of an introduction to my own biography, and the way that AMP actually came about was that me and my AMP co-founders, back already in around 2014, 2015, were building and operating renewable energy systems in sub-Saharan Africa for a company that was owned by E.ON, which is a big German utility. And at the time, we were developing rural mini grids with containerized solar and battery systems. We quite quickly realized that the data from those systems and the digital operations of them is going to be crucial to this actually being a successful business. So I ended up back then building essentially what was one of the early versions of AMP to pull data from all of those assets and use it for remote monitoring and operations. In 2018, there was an opportunity to take the software platform that we built and sort of develop it independently of E.ON. So we did that, and that's when AMP was born. So this year, it's been about 5 years that we've actually been pursuing this as an independent business. And what we mostly focus on is remote monitoring and management for distributed energy companies. For companies that own and operate portfolios of renewable energy systems, usually commercial and industrial scale. So let's say about 50 kilowatts at the low end and 5 to 10 megawatts at the high end. And we work with a lot of hybrid systems in particular. I'm going to run through just a little bit of our company presentation, showing a few of the things that we do. But I'll try and sort of touch in particular on some of the most interesting topics that we see around how companies like that, especially in the sub-Saharan African context, deal with data and data unification, and some of the best practices around that maybe some of the viewers will find particularly interesting. So with AMP, what we mostly look at is data-driven operational excellence. So taking the data from the systems that are operating, performing a set of analytics on that data and transferring that into operational intelligence, into better, more streamlined technical and commercial operations for our customers. One of the things that we're most proud of is the integrations that we have. And I'll probably spend most of today talking a little bit about that, because at the heart of this sort of operational intelligence that's driven by data is, of course, the data itself. Before we're able to do anything, really, we need to have a good, reliable data set from all of the sites in a given portfolio. So as I mentioned, we do that, and we have a level of unification that happens where we have both integrations with vendor APIs. So, for example, most inverter companies these days, like Victron, SMA, Schneider, will provide direct API connection with their remote monitoring, so we can start streaming data from them immediately. We also have data loggers that we're able to deploy for systems where that kind of connectivity is not already there. And then on top of that, we build a number of things, including applications and APIs, which I'm going to say a few words about. And before I go into that, once you have that data, one of the important things that's required to get value out of it is a sort of digital twin. So taking all of the different data streams, and I'm going to give an example here. So we have, let's say, a fairly complex 1 megawatt PV asset, which also has diesel generator and batteries. Assets like that for commercial industrial purposes, we see as being increasingly common across the African continent, given that they can deliver energy reliability, they can deliver energy cost savings, and they can even these days be used for things like arbitrage on the market. So we see a lot of customers with industrial operations in particular deploying assets like that. So with that kind of complex solar, battery, diesel setup, you are going to have quite a number of different data streams that need to be processed, that they need to make sense of. So before we can deliver additional value on top of that, we take those data streams and we build this digital twin. This representation of that system and all of the different parameters of its operations that we then can present to our users. Taking a step back and a little bit about where we are now, we do have, I think this slide is a bit outdated, so it's over 1,000 systems. I think these days it's close to 2,000, really across a very wide range of geographies, but with a very strong focus on Africa. As I said, Africa and Tanzania and Sierra Leone in particular are the countries where we got started with E.ON, and is where what we consider our home market to some degree. We work with a number of the biggest developers across, for example, Nigeria, Kenya, and South Africa, which are, again, the biggest economies in Africa. So most companies that you may know of who are deploying renewable commercial industrial assets will be on our platform these days. So just one case study to give you a taste of what we do. And I mentioned the sort of hypothetical system. This is a bit less hypothetical. This is with a couple of projects with Ofgen Africa, who have quite a range of commercial industrial installations. And for example, we have Williamson T Kenya, which is 1.5 megawatt solar PV with a 4 megawatt hour Tesla battery. Or we have UAP in Juba in South Sudan, which is a smaller PV and battery system, but still quite a complex hybrid, where there's a combination of sort of Tesla power pack inverters, Tesla power pack storage, SMA inverters, and DAC generator controls, where we're able to take in all of that data and build a really accurate picture of what's happening at the site, and then deliver the value. And I'll say a few words about what that value looks like. So our main offering, which is AMMP OS, involves, for a start, just having a set of dashboards where you can see exactly what's happening on your sites. We can then, not just on a given site basis, but for the entire portfolio, see what's happening at every given site. So you get let's say a big table as a basis that shows you the status of every given element of generation. And then we have things like instant alerting, which are obviously going to be very important if you have technicians who need to attend to any irregularities at these sites. Building up on that, then we have things like predictive maintenance. So over time, we can look at whether systems are performing the way they should be. This is particularly important when you have hybrid systems with diesel generators, for example. Obviously, diesel is quite pricey. So if there are any inefficiencies in the diesel performance, that's something that should be taken into account. Let alone things like diesel theft. Similarly with batteries, which are again one of the major cost components for any systems with batteries, it's important to take stock of how they're performing, and in particular, if needed, make improvements to performing conditions. And we've got some white papers on that I can point you to on our website. Secondly, on a higher level, here we mentioned reliable energy readings, and we've really identified those as being one of the key cornerstones of running a successful renewable energy business. Most of our customers all of our customers deeply care about how much energy is being produced by their systems. That is a universal truth. Whether it's a PV system, whether it's a diesel system, you want to know what the output is. For a PV system, of course, that will drive things like performance measurements. But more so than that, for many of our customers, the exact level of output is directly correlated to what they can charge their end users. Just to give an example, we work with a lot of companies that essentially have an energy as a service business model. Now, that means that at the end of the month, you're going to bill your customers for the energy that they've consumed. So you need to have a reliable measure of what that energy actually was in order to do that. For many other customers, if, for example, you're a professional asset operator, you will have a set of service level agreements, let's say, that will determine whether you get paid as you would as an operator, or whether there are any damages to be paid. And those service level agreements will generally depend on performance, which is tied to these energy readings. So having reliable energy readings is paramount. It is something that we always focus on. And finally, I mentioned that tracking performance really is something that will be at the heart of all of these operations. Here are just a few examples of the kinds of interfaces that we've built. Unfortunately, we don't have a demo environment live at the moment, so I'm just sharing these sort of more loosely. But we really have a lot of flexibility in terms of how the data is presented. We really work closely with our customers to make sure that it fits their workflows, that we can feed data into what they do in exactly the right way. So I talked a little bit about these reliable energy readings on the last slide. And with many of our customers, what we're doing now is we can take the data that's coming from all of their sites, in particular the energy data, and we can feed that into things like accounting processes or other reporting processes that they have to directly create those sort of data products. Let's say, be it a report or be it an invoice or something like that. Now, I want to take a quick, let's not call it an aside, but a quick deep dive into one particular aspect of what we do, which is the AMMP data API. I talked so far about the AMMP OS, which is this sort of monitoring platform that we provide for our customers who are running portfolios of renewable energy systems. The API is a part of that. It's the data unification part of it. And it's basically taking all of the different integrations that exist out there, all of the different vendors, and then being able to have a single, let's call it a single data plane, a single point of access into all of that data. So no matter whether you have Huawei systems or SunGrow systems or SolarEdge systems, you can access data from all of those systems in the same way. And that becomes quite important in a number of different scenarios. So I'm just going to jump over this, but one case study that we have here is with the Sun Exchange, which is in South Africa. They're essentially a financier of solar assets. In their portfolio, there's really a wide range of different technologies and different vendors that they have. And for them, it's very important to be able to get data into one place, to be able to show their customers what's being generated, and to be able to then do calculations on how this is all being monetized. So this is, again, we're tying up different things here, but we have the reliable energy readings and the vendor agnostic data sets. And this, just to talk a little bit about the benefits of the API offering in particular, this is more targeted, I guess, at, let's say, more sophisticated companies who have their own internal data operations, but are really interested in having an easy way to access data across different kinds of systems and different vendors. And I'm going to switch now very quickly to my browser. So we have we have on our website amp.io, that's AMMP.io, an integrations page, which is generally the most up-to-date view of the different manufacturers that we integrate with. And for anybody watching this, you can just kind of come to this page and see, are the inverter vendors that I'm interested in already part of AMP, or if not, we're always open to add new ones, and we're adding new integrations on a weekly basis these days. So this is something that we have, and one of the things that's then really powerful is what you can do with that data. So I talked about an API, and here it's actually listed under our product, so I can just click on the data API. This kind of captures some of what I talked about. So without AMP, if you are trying to build a database application, you need to have separate integrations with all of these, and with AMP, you can just have all of that in one single connection. Have all your data be standardized. So if I was to then look at just some of the documentation here, which is directly linked, this can already give more technically savvy viewers a sense of what the kind of what the kind of data is that they can get via this API. So here we have some examples, and then actually at the bottom of this page is also the schema. So, for example, what does a battery data set looks like? What does a PV-AC or PV data set look like? So this is what users can do on a pure, let's say, software basis. So they can tap into this API. But one of the really cool things that is also really noteworthy is, we went back to the integrations. We also have these software add-ons. So we can take the AMP data and directly via this API feed it into a number of different things. We have some battery and PV analytics, as well as maintenance software that we can directly integrate with. We have Slack and Microsoft Teams alerting that we can do. But then some of the really cool stuff is that we have, for example, Google Data Studio or Microsoft Excel or in Power BI connectors. That means that if you have an Excel spreadsheet where every month you're entering data from all of your different sites, and you're sort of trying to aggregate performance data, aggregate output data, and you're doing reporting based on that, what we can do with AMP is have that data be actually auto-populated. I'm not even talking about having like a CSV or like an Excel export from AMP on a monthly basis. I literally mean you can pull up Excel, click a button in Excel, and have all of that data be populated live from the actual systems. So I think that that's something that's really quite powerful, and we're seeing it transforming the way that several of our customers are doing business. This is a slight tangent, but we also have solar irradiation data. So we can use that together with PV, observe PV performance, do performance ratios and things like that. That brings a whole new angle to the sort of diagnostics that we can do. So one of the last things I thought I'd maybe talk about, and for this I'm actually going to switch to presentation, which I think does a better job of explaining it, is the AMP Edge. So we are able to also get data from systems that are not online, and really take some of these very complex systems, and with a data logger, augment all of the data that we're able to get directly from vendors' monitoring platforms to build a really accurate picture. So we only deploy this, I'd say, on an as-needed basis. Most of the time, we try to essentially do this, to get all of the data from these vendors via their own monitoring platforms without any additional hardware on site. But there are occasions when we do need additional hardware, so that's what we can do with the AMP Edge. So I think I'll conclude here for now, just to leave you with this, the parting thoughts that it's important for larger portfolios of systems to have their data unified. We can talk a little bit about that maybe in a minute. But it's important to do that, because if you don't have unified data, you're generally going to be fighting fires. You're generally not going to have a view of what's happening across your portfolio. And as that portfolio grows, things get really quite chaotic. And the other point is that with the AMP API in particular, it's possible to really streamline these data flows. So not just building a particular monitoring platform, but really any sort of data products on top of that, any sort of analytics that may be needed of all sorts, not just something that we've already implemented in the platform, but anything that our customers can even dream of. So this is it for now. Thank you, Jeannie, for giving me the chance to share this with your viewers.
Thank you very much for a very good presentation. It was awesome and it has a lot of info, and I hope the audience find it more helpful and interesting. And hopefully, as they are seeing some emails and contact, they will reach out to you for more info and clarification. Can I please ask you to stop sharing? So I got some question when you were presenting, and please be raising a question and you'll be giving your thoughts and the answer. At what stage of portfolio development does the data unification start to play alone?
Yeah, it's a really good question. I think a lot of people who are developing renewable energy systems and who are deploying renewable energy systems might have this on their mind. I'm sort of reflecting both on our experience of running these systems with E.ON back in the day, and also when we talk to many of our customers or potential customers. I'd say that once, if you have sort of like 1 to 10 systems that you're running, you're generally still sort of figuring things out at that point. You're maybe experimenting with a few different vendors, experimenting with different system designs, and maybe even different business models. If you find something that works, you're probably going to start rolling out more systems. You might get to like 20 or 30 systems, or even 50 systems. Now, if you've sort of standardized on a given vendor for those first 20 systems, then you're maybe in a place where you can use the vendor's monitoring. So let's say if you just have a lot of SMA systems, or a lot of solar systems, you can probably get away with using the sort of SMA like NXOS monitoring or the Solus web portal, and that might tick your boxes. What we see in practice is that as our customers get to maybe 20 or 30 systems or 40 systems, that's when things start to get really quite complex. Even if you're using a single vendor, you start to generally need to have functionality across all of those sites that you can't anymore get through the vendors on monitoring portals. And we had one example in South Africa where a customer was using SolarEdge before starting to use AMP. With SolarEdge, they needed to have output data for all of their systems for every month, because they needed that data for billing. Now, what they would often generally have to do is go to the SolarEdge portal and then download data for every single system, and they had about 30 systems in their portfolio, on a week-by-week basis, and then compile all of that data into monthly output. So obviously something like that gets very unwieldy and very time-consuming. If you have pain points like that, pain points around data management, that's generally when data unification and data management like this will start becoming important. Just one other thing to add maybe is, we see at the same time we see data unification on people's minds quite early on in some cases. So sometimes we have people who've got, as I said, like 5 to 10 systems, and they're already thinking, hey, how do I make this really scalable? I would say to them, yes, this is an important question, and we should certainly talk. But the real value that you see from adopting a solution that does the data unification for you will probably be somewhat down the line when you hit like 30 or 40 systems.
Thank you very much for the answer, a very good answer. Second question that I have, how can data be obtained from devices that don't have online monitoring, like diesel generators?
Yeah, that's a good question. As I mentioned, a lot of the integrations that we have are with vendor monitoring platforms directly. So let's say Windstream with SMA, NXOS, SolarEdge, all of these other logos that I showed. But at the end of the day, many customers will still have, let's say, diesel generators, as the question asks, or diesel level sensors, or maybe radiation sensors or others that don't directly connect to an online monitoring system. So that's where we then have the AMP Edge component of the solution. So that's a small, very cost-effective data logger that customers can plug in at their sites. That will then collect data from things like diesel generators that may be offline. And the really nice thing is that data gets combined with any of the other data that we're able to get from the vendor monitoring platforms in quite a seamless way in these digital twins that I talked about. So we have quite a clean solution for doing that for our customers.
Thank you very much. The following question that I have, is it possible to automatically check for under performance and other anomaly?
Yeah. Well, I think the capabilities in that regard are getting better and better. One of the things I only very briefly touched on is the fact that we have solar radiation data in the platform as well, from an external source, from let's say from satellite imaging. What that means is that we can then look at solar generation from the plants and correlate that with what the actual historical radiation data is at any given time, and we can then detect underperformance proactively. So that's definitely one thing that we can do. I mentioned a little bit about batteries, in particular battery aging. We've developed some algorithms that look into that. And we also have some partners that have their own algorithms that can look into that. We work together with Smart Helio, which is one of the premier solar analytics companies, to do even more sophisticated analytics there that really goes on a sort of string and module level. So we can feed all the data that AMP is collecting into their analytics platform and get insights that way. So we can then proactively alert our customers to any issues that are on the site. So yeah, indeed, capability is getting better and better. We're also doing a lot of testing and experimentation with AI capabilities that I think are going to be quite transformational here.
Great. So it seems like I've the last question. It's a very long question, but hopefully it's helpful, and we really want to understand more. With some system portfolios, there might be complex relationships between financial owners and operators. How do you ensure that the right stakeholders can get access to the appropriate data?
Yeah, so I think this recognizes one of the complexities exactly that exists here. So if I was to sort of think of some of the situations that we've seen, we have, for example, situations where somebody like the Sun Exchange that I mentioned in South Africa has funded a particular system. There will be another party which has maybe built and operates the system, so the O&M, the EPC/O&M provider, and then you have another party which is the off-taker of the energy. Now, what we've done in that regard with AMP is to recognize that these different relationships exist, and we have a mechanism for very flexible access control. So for any given system, and we can go into like more detailed parameters, but for any given system, we can basically say, hey, this system should be visible by this financier because it's in their finance portfolio. It should be visible by this EPC because they're operating it and need to have operational data from it. And it should be accessible by this end user because it's on their roof and they want to know how much energy is generating. So when each of these users logs into AMP or into our API, they can see exactly the systems that they have access to in there. And things can be quite flexible. So for example, one EPC can, for example, have access to a number of systems across different financiers, or a single financier can have systems that are being built by different EPCs. So we get a bit of a matrix here, but we have put quite a lot of thought into making this work quite cleanly. And we have quite a powerful set of access controls where even a user can go into the system and click and say, hey, this other person should also have access to the system because, I'm the financier and they're my EPC or vice versa or something like that. So that's definitely something we spend quite a lot of time on.
Interesting. I feel like I'm satisfied with the answers, and I hope the audience do as well. So we are at the end of today's session. We learned a lot. Thank you for accepting our invitation. Maybe just 1 minute to remind the audience your email and the contact so that maybe some can take some notes to reach out to you after the session.
Absolutely. Maybe it'll be helpful if I just share that screen again. So this is me. It's Svet SVT dot BAJLEKOV at AMMP dot. Don't hesitate to send me a WhatsApp message as well if you want. Yeah, that is it. I'll leave that in case anyone wants to take a screenshot.